Welcome. This is Unit Geometry A, Unit 8, Lesson 7, Proving Similar Triangles. So you recall the triangle that, well, let's start with the definition of similar triangles. You recall the definition of congruent triangles. Definition of congruent triangles is that all sides and all angles are congruent. The definition of similar triangles is all sides are proportional and all angles are congruent. Okay, let's specify what that means in this particular case. Triangle ABC is similar to triangle DEF. Means that AB, the ratio of AB to DE, notice the first two, is equal to the ratio of BC to EF, second two to second two, is equal to the ratio of AC to DF, first and last, first and last. Okay, and angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. So that would be the definition of similar triangles as applied to the statement triangle ABC is similar to triangle DEF. The ratio of the sides is the same. That's another way to say they're proportional. And all the angles are congruent. Now let's take a case, a specific case, and we want to prove something called the mid-segment theorem. So here's what the mid-segment theorem says. Okay. I'm going to start by drawing a triangle. Draw a triangle. Drawing a triangle. Just any old triangle will do, because this is true of all triangles. Okay, and let's draw a triangle like this, an acute triangle here. Isn't that triangle cute? Oh, I said acute, not cute triangle. Yeah, okay. And I'm going to find the midpoint of two sides. Midpoint of two sides. So let me grab my compass and let's darken our lines here a little bit, because I'm not interested in preserving these, but I'm going to construct the midpoint of two sides. So the midpoint of two sides. Hopefully I've got enough. Oh, just barely. Midpoint of that side. And midpoint of this side. Okay. And let's connect the two using my straight edge and compass. The purpose of this is just to find the midpoint. There's the midpoint right there. And here's the midpoint right here. Okay. And no, you're not being tested on whether or not you can construct the perpendicular bisector. This is just the perpendicular bisector of both sides. So here's the one midpoint. And here's the other midpoint. Now you recall we did a section where we found the mid-segment, right? Mid-segment connects a midpoint to an opposite vertex. In this case, actually that's the median. Median connects a midpoint to the opposite vertex. In this case, we're finding something called the mid-segment. mid-segment. The mid-segment connects two midpoints. Okay? And what I wanted to prove is something called the mid-segment theorem. Which says the mid-segment is parallel to and 1/2 the opposite side. Parallel to and 1/2 the opposite side. Okay, so let's see if we can figure this out here. Since I drew it as a mid-segment, here's what we know. The midpoint divides this line segment into two congruent parts because it's a midpoint. This midpoint divides this into two congruent parts. Let's label some vertices. A, B, let's try that again. Hitting fat fingering buttons. A, B, C, D, and E. Okay. So statement. We always start with the given. We're given that AD is congruent to BD. Or in this case, I'm going to simplify it and save myself a little bit of work by saying AD, the distance between A and D, equals the distance between B and D. And I'm going to say AE equals EC. And that's statement 1. And the reason I know is that's what we're going to be given. Okay? We want to prove, and I don't know what number step this is. First of all, that DE equals 1/2 BC. And I want to prove that DE is parallel to BC. Okay, so this could be two separate proofs, but we're going to try and squeeze it all in. All right, so let's see what we know. We've got the starting point and we've got the conclusion. All right. Where are we going to go? Well, let's do this. Both triangles share angle A. So let's go blue here. So statement 2, I'm going to squeeze these up in here. I'm not sure how many steps we're going to need. Angle 2, or angle A, is congruent to angle A. Angle A is congruent to itself. And that is the reflexive property of congruence. Anything's congruent to itself. So I've got an angle congruent to an angle. And this angle is shared in triangle ADE and triangle ABC. Okay? All right. And so let's see. Step 3, I'm going to say that AB equals AD plus BD. And angle AC equals AE plus EC. And that is using the the segment addition postulate. Segment addition postulate, which says we can add two small segments to make a large segment. Okay. All right, so we've got AD equals BD, and we've got AB equals AD plus BD. All right, so let's see. AD equals BD. And AD, oh, so here we go. So AB equals, if AD equals BD, then I'm going to substitute AD plus AD, right? I just traded BD for AD because AD equals BD. That's substitution. So step 4, substitution. Okay, and same step. AB equals, so what about AC? AC equals AE plus AE. Same thing. AE equals EC, so I traded EC for AE. Substitution. Okay. Step 5. AC equals, or AB equals 2 times AD. And AC equals 2 times AE. That's adding like terms. Add like terms. Okay, division. 6. AB is to AD equals 2, dividing both sides by AD. And AC divided by AE equals 2. That was by division. We divided both sides by AD. Let me show you what I did here. So we have AB equals 2AD, divided both sides by AD. AD's cancel, we get AB over AD equals 2. So that's the division property. So step 6. Division property of equality. Of equality. I can divide both sides by the same thing. All right, so AB is to AD, AB is to AD so they're equivalent, right? Let me get rid of this down here. I'm just going to remember what our conclusions are. Then we're going to need some more space. Didn't leave enough room. Okay, so 7, AB is to AD as AC is to AE. Okay, so 7, they're both equal to 2, so they equal each other. That's the transitive property of equality, transitive property of equality. All right, so guess what I've got? I've got these sides proportional, and I've got these angles congruent. So that's an angle, a side to a side, a side to a side, side angle side, side angle side. So the triangles are similar. So 8, triangle ABC, similar to triangle ADE, by side angle side similarity. Now we've got it. Now we can use the definition of similar triangles. So 9 we know that angle C is congruent to angle AED. So that's this angle is congruent to this angle. Since angles in similar triangles are congruent, or we could just cite the definition of similar triangles. And 10, we know that DE is parallel to BC since, that's 9, not 10, this is 10, since by the definite, or by the inverse or converse of the corresponding angle postulate. Boy, we're really running out of room. Here, let's shift things around a little bit. Okay. So that's one of the things, parallel, that we wanted to prove. We also wanted to prove that ADE is half of BC. So that's just rearranging one of the previous steps here. DE, okay, so our scale factor is 2, right? So I can say, because corresponding corresponding sides are proportional, I can say that DE, or BC over DE is 2. Okay, 11. And 11 is, the reason is sides in similar triangles are proportional. They have the same ratio. And then 12, we're there. DE, okay, times 2, or let's do it this way. BC equals 2DE. And I'm going to squeeze this into one step here. DE equals half BC. By 2 steps there. By division, no, multiplication, followed by the division property of equality. Whew. All right, so we started with the midpoints, the mid-segment, and we ended with DE is both parallel to and 1/2 the opposite side. Wow, what a proof.